Hi, this is Saka, and I want to talk a little bit about this polarity stuff we talked about in class today. So, let me begin talking about things that are polar, because I think that might be a good place to start. So, polar covalent. So, for it to be polar covalent, a few things have to be true. One is it has to be non-metal, non-metal. Okay, it's got to be non-metal, non-metal. Otherwise, if it's going to have that big of a difference in electronegativity, it probably would be ionic then. The other thing is you have to have polar bonds within the molecule. It doesn't have to all be polar bonds, but there should be some. Oops, I pressed down too hard again. Okay. Okay, so there has to be polar bonds within the molecule. Uh, the third thing that has to be true is when we look at the VSEPR, so remember our Lewis structure, we have to look at that too. Okay, as long as the central atom has at least one lone pair, it will be polar covalent. And we'll do some examples to test this out to see what's polar covalent versus what isn't. Okay, so that's polar. Nonpolar is a little bit more difficult. Okay, whoops. So let me erase that. And so let's talk a little bit about nonpolar covalent. So what happens? There we go. What happens with nonpolar covalent? This one's a little different. Okay, for this one condition that's nonpolar covalent is when you have the same atom type bonding to itself. And so what I mean by that is, like, remember today in class we did Cl, Cl. This would be an example of nonpolar because the difference in electronegativity would be 0. Okay, so that's the easy one. Another one to be aware of is CH. CH bonds are nonpolar, always. Okay. Um, the third situation is when you have a difference in electronegativity somewhere between 0 to about 0.4. Okay. We called this today. We call this in class mostly covalent, but a lot of a lot of a lot of a lot of scientists might call that nonpolar covalent. You wouldn't be too far off if you concluded that. Okay. We'll try and make it obvious so the judgment call isn't so difficult. So these are three of the situations, and then there's a really difficult situation which I'll put on its own page, which is situation number 4. And this is where you have polar bonds, but God, my writing's terrible, but a non-polar molecule. Okay? So this is what happens when you have polar bonds but a non-polar molecule. Two things need to be true for this to happen. One is you need um, the center. Keep doing that. The central atom has 0 lone pairs. Okay. The other thing that has to be true also is the central atom is surrounded by the same atom. Okay? So both of these things need to be true. So both of these must be true. So both must be true. Otherwise, if this isn't true, then it doesn't work. And so let me give you some examples of how this works, okay? So let's use some examples here. Of course, now when I press down, it won't work. There we go. So let's say we have something like, and these are from your sheet that I gave you. Let's say we have something like, oh, I don't know, like C F4. So with CF4, the Lewis structure looks like this. So if you remember how to draw your Lewis structures, I'm going to use dashes because my dots aren't working so good on this pad. And then we know that the F's all have an octet, so I'm not going to draw those in. So individually speaking, the CF bond, so the CF bond is polar. Okay? But look at what's happening here. If we draw out the charge lines here, notice that they're the same in all directions, right? And so what ends up happening here is because the pull is equal in all directions, this is a nonpolar molecule. But remember, both things are true. One is the central atom. Does it have any lone pairs? So no. So C has, oops, it's not Hayes. It has 0 lone pairs, or LP. And is the second condition true? Oops. So for condition number 2, C is surrounded. Is it surrounded by? Is it surrounded by the same atoms? Yeah, it is. The F's are the same all around. So because of this, non-polar. Okay. Another example that's really quick. And this one I think was in your homework. I forget what it was. It was like C H2 Cl2 or something like that. So it would look like this. You have C, you have Cl, Cl, H, and H. Okay. So again, let's look at our central atom here. So is the first condition true? So C has 0 lone pairs. That's definitely true. And the second condition, C is not surrounded by the same atom. Oops. See, it's not surrounded. See how it's Cl here and Cl here, but not with the H's? So here we would have this and this. But notice that we wouldn't draw them for the CH bonds because those are nonpolar. So the Cl is polar, the CH nonpolar, but it doesn't matter because of the polarity and because both conditions aren't met. This is a polar molecule. Okay. I'll do some examples a little bit later. I'll probably go through your homework and run through some of those questions to try and give you some help with that as well. So hopefully this is helpful to you, and I'll see you soon.